Hello everyone, welcome to today's class, Organic Spectroscopic Analysis. In previous lectures, we have learned about the principles of mass spectrometry and the ion sources. In this lecture, we are going to learn another important component of mass spectrometer, mass analyzer. There are sorts of mass analyzers on different mass spectrometers, such as magnetic sector, quadruple mass filter, time of flight, ion trap analyzer, FTMS, and tandem MS. Magnetic sector is based on fixed field magnets. Magnet sector machines operate as high-resolution instruments. Sector machines operate with high voltage on ion sources, commonly 8 kV. Quadruple mass analyzer uses a combination of RF and DC voltages to operate as mass filter. It has 4 parallel metal rods and lets one mass pass through at a time. Ions scanned by varying the DC and RF voltages cross the quadruple rods. Quadruple mass analyzer is compact, inexpensive, and can be coupled with GC, and so can work as GCMS. Ion trap functions both as analyzer and ion storage device. Ions are produced or introduced into the ion trap, trapped, and can be progressively injected by wrapping of the RF voltage. The trapped ion can also be introduced to undergo dissociation and hence produce the mass spectrum, which is a tandem mass spec with the one analyzer. Time of flight analyzer measures the time it takes an ion to travel a specific distance. The ion is initially accelerated by a high voltage, which from 20 to 30 kilovolts. Different mass ions will accelerated into the analyzer with initial velocities proportional to their masses and subsequently arrive at the detector at different times.
Agilent's patented nebulization technology produces finer droplets and delivers more ions to the mass spectrometer. A second nebulizer introduces reference mass solution that ensures continual mass axis correction for the best possible mass accuracy. High-volume counterflow drying gas reduces noise related to incomplete drying of solvent droplets and keeps the sampling capillary and ion optics cleaner for reduced maintenance. A thin skimmer aperture, carefully matched hole size, and short capillary to skimmer distance reduce beam broadening. An on-axis octopole ion guide provides nearly 100% ion transmission over a wider mass range. Patented lenses enhance high-mass ion transmission and increase sensitivity over a wider mass range. The quadruple mass filter allows only ions of the target mass to pass through. The hyperbolic shape of the rods enhances ion transmission and spectral resolution. The microchannel plate detector converts the ion signal from electrons to photons and back to electrons. This electrically isolates the high-voltage light tube and front of the detector from the signal passed to the electronics. ADC digitizer electronics provide extremely high mass accuracy over a broader dynamic range. The 6510 offers outstanding in-spectrum dynamic range for a time-of-flight instrument.
Is a versatile analytical technique to detect, characterize, and quantify mixtures of biomolecules or large organic molecules. MALDI stands for Matrix-Assisted Laser Desorption Ionization. This ionization method involves a laser striking a matrix of small organic molecules to make the large, fragile analyte molecules into gaseous ions without fragmenting or decomposing them. TOF stands for time of flight, a mass spectrometry method that separates ions by their mass-to-charge ratio and quantitatively determines that mass-to-charge ratio by the time it takes for the ions to reach a detector.
Fourier transform ion cyclotron resonance mass spectrometer, which is FTICR-MS, is a high-resolution MS with very high precision and is the most expensive MS so far. Ion assumes a circular orbit in a molecular field. When excited with RF with the characteristic frequency, ions absorb energy, resulting a larger radius. Before excitation, ions are in their natural cyclotron radius within the magnetic field. During excitation with the radio frequency, ions are excited to a larger cyclotron radius. After excitation, the cyclotron radius remains in its larger state. The electronic trapping potential is scanned to bring each mass-charged ion in resonance with RF. Resonance condition that the particular mass-charge ratio can be detected with high accuracy. For tandem mass spectrometry, ions are separated in the first mass spectral analyzer. Specifically, parent ions, pass one at a time in a field-free collision chamber. Collisions with helium result in daughter ions. Second mass analyzer produces mass spectrum of each parent ion in the first MS. Hybrid MS are possible for large molecules and mixtures. This is the picture of a quadruple tandem mass spectrometer. This table compares the features of different mass analyzers according to the mass-charge ratio range, resolution, sensitivity, and price. So for this lecture, we have learned about mass analyzers. Let's continue studying MS in the next lecture. Thank you.